In this question, we've been told that a ball of mass 2 kilograms moves on a smooth horizontal surface under the action of a constant force F. The initial velocity of the ball is 2I minus 3j, and 4 seconds later it has velocity 10I plus 9j. I and j are perpendicular, horizontal unit vectors. We're first asked to make reference to the mass of the ball and the force it experiences, explain why it's reasonable to assume that acceleration is constant. Well, we have been told that there's a constant force being applied. And mass, there's no reason for the mass to be changing, so the mass is also constant. So, just thinking about F equals ma, if both the force and the mass are constant, we can reasonably expect that the acceleration is also going to be constant. So, because we have those two constants in force and mass, we can anticipate acceleration being constant as well. We're first asked to find the magnitude of the acceleration experienced by the ball. So, we can find acceleration making use of SUVAT. Initial velocity is 2 negative 3, final velocity of 10.9, unknown acceleration, but we know the time is 4 seconds. So, we can use a SUVAT equation, v equals u plus at. SUVAT equations work with vectors as long as we don't need to divide or multiply vectors with each other. Rearranging, we get acceleration of 2, 3. We will ask for the magnitude of this acceleration. So we can find the magnitude by applying Pythagoras. If we think of the diagram, we've gone to the right by 2, up by 3, we're looking for the diagonal length. The diagonal length is root 13 to 3 significant figures, 3.61. We've been asked to find the angle which the force F makes with the vector I. To find F, we can use Newton's second law, F equals ma, and we'll substitute the mass is 2 and the acceleration we found to be 2, 3. So this is the vector 4, 6. Okay, let's just go a quick diagram of 4, 6 so we know what it looks like. 4 to the right and up by 6. And this diagonal is the actual vector. We want the angle that the vector makes with I. I is a horizontal vector starting at the same start point. And we're looking for theta. So we can go ahead and set up an expression. Tan theta equals 6 over 4. Tan theta must be 3 over 2. Theta is inverse tan 3 over 2. And here we get our answer, 56.3 degrees. That is the angle F makes with the vector I.